feedback. We are finding D. D is your D sensitivity. D is equal to 1 plus beta into AV. So beta, it is 1 because VF and V naught are same, okay? So if D is equal to 1 plus AV. AV is HFE RE by RS plus HIE. So take LCM and have this is the expression for capital. Why we are finding this capital D? Because whenever you are going to find the parameters with feedback, we'll be either multiplying or dividing by capital D. It is divided by 1 plus beta A or multiplied by 1 plus beta A, right? So every time writing the 1 plus beta A is very big. So we compute a parameter called D sensitivity, D, capital D, and we use this one for all other parameters. So when you are applying negative feedback, the voltage gain will reduce. So AVF equal to AV by D. AV, this expression divided by D. You can see the common terms will get cancelled. So AVF equal to AV by D, HFE into RE divided by RS plus HIE plus HFE into RE. So this is the voltage gain of the amplifier with feedback. And definitely you see the denominator. HFE is a very big term. RE is a very big resistance. So HFE RE will be very, very large when compared to RS plus HIE. So RS will be 1K, HIE is 1K, but HFE into RE will be close to 100K. So HFE into RE is very, very large when compared to RS plus HIE. So RS plus HIE can be neglected. So the AVF will be HFE RE by HFE RE. AVF is approximately equal to 1. So theoretically, whatever we said, the common collector amplifier has a gain of 1. That is proved mathematically and practically here. It is approximately 1. So practically it will be less than 1. Okay, practically it will be less than 1. So AVF is approximately equal to